And we're back in Better Than Ever in 10.2, where we're dealing with mole to mass conversions and mole to volume relationships. In the last podcast, we showed you the first part of our molar roadmap, and we did a conversion where we took grams to particles. In this podcast, we're going to start off by taking particles to grams. So in example number 3 here, it says how many moles are in, and let's just say we're going to go with 8.15 times 10 to the 22nd molecules of ammonia, which is NH3. Okay, so the first question is how many moles are in that amount of molecules? So again, the strategy is to write whatever you're starting with, 8.15 times 10 to the 22nd molecules of NH3, and we're trying to get to moles, and I like to put moles in whatever I'm looking for all the way over on the far side just so I can keep an eye on it. So using our molar roadmap, you want to locate where you're at, so we're going to scroll back up to that thing. We are in particles. Okay, I'll put a star by that. We're in particles, and we want to get to moles. So in order to go from particles, which includes molecules here, to moles, you have to use Avogadro's number. So let's go ahead and do that. We'll go ahead and change back into blue. Scrolling back down here. Now, which fraction do we want to use? 1 over Avogadro's number or Avogadro's number over 1 mole? Well, since we're already in molecules and we want to get that to cancel out, we want to have Avogadro's number molecules of ammonia over 1 mole. I'm saying actually the 1 mole on top, under 1 mole of ammonia. And of course, the molecules of NH3 will divide out with molecules of NH3. You're left with moles as being the only unit, and that's what you're looking for. So making sure that you use your parentheses around each term, you're going to take 8.15 times 10 to the 22nd divided by Avogadro's number, 6.022, times 10 to the 23rd. Yes, you can multiply by the 1, but that's not going to do you anything. So just the 8.15 times 10 to the 22nd divided by Avogadro's, and I'm coming up with 0.135 moles of ammonia, NH3. All right? So far, so good. Now, in the second step, we're going to take that many moles and turn it into grams. How many grams are in 0.135 moles of NH3? So again, we'll go ahead and write that off to the side, 0.135 moles of NH3, and we're trying to get into grams of NH3. So let's go locate where we're at on the molar map and see where we got to go. Well, we're currently in moles, so I'll put an asterisk right there. We're currently right there, and we want to get to our mass in grams. So what do we use? You use, well, I'll keep with the asterisk here, use the molar mass, which comes off from the periodic table. Now, NH3 itself is not on the periodic table. We only use elements. So you have to do a little scratch work. So if you want to figure out the molar mass of NH3, nitrogen weighs 14.01. All right. The hydrogen weighs 1.008, but you have 3 of them. And then you're going to have to add all those up. And when you do that, you should come up with 17.03 grams of ammonia, which equals 1 mole of ammonia. All right, that's what the molar mass means. Oftentimes we write it grams over mole, just like that, which, excuse me, actually means you can put 1 mole of NH3 on the bottom. Now, which direction do we want to go with this? Well, if we have moles of ammonia on top already, we're going to want to have our 1 mole of NH3 on the bottom, and we'll go ahead and put the 17.03 grams of NH3 on top, so that the moles divide out with moles, top and bottom. You're left with grams. You're looking for grams, and so when you perform the calculation, 0.1 0.135 times 17.03 divided by the 1, I'm getting 2.30 grams of NH3. So that is the mass in grams of 0.135 moles of ammonia, which is the same as 8.15 times 10 to the 22nd molecules of ammonia. Now, just like before, you could have done this all in one step. With starting with the 8.15 times 10 to the 22nd molecules of NH3, the first step, of course, the first step, of course, is to change it into moles. What you're going to find is that you're going to have to change everything into moles most of the time. So you use Avogadro's number to do that. Of course, you put Avogadro's number on the bottom so that the molecules unit will divide out. And then before you do the calculation, because you are already in moles, the next calculation can put moles on the bottom. 1 mole of NH3 is going to be under the 17.03 grams of NH3. The moles will divide out with moles. You're left with grams. You're looking for grams. And so you'll take your 8.15 times 10 to the 22nd times 1 divided by Avogadro's number times 17.03 divided by 1, and you'll get the exact same answer of 2.30 grams of ammonia. And you can do it all in one step. All right? So, we've shown you how to go both ways, going from grams to particles and particles to grams, using the molar roadmap, which you will be able to use on tests and quizzes. You don't have to have this thing memorized. All you need to do is locate where are you at, where do you need to get through, or where do you need to get to, and it's always going to have to go through moles first. In the next podcast, we'll be adding to this molar roadmap, we'll be adding volume of a gas. We'll see you next time.